This video is about the bond strengths and bond lengths of carbon. For a molecule to be sturdy, it must have relatively strong bonds. Carbon forms very strong bonds with a lot of different elements. Bond strength can be measured with bond dissociation energy, or how much energy is required to break the two atoms that are bonding apart. So in other words, a higher bond dissociation energy means you have a stronger bond. Like all other elements that form covalent bonds, carbon follows these following general trends when it comes to bond strength and bond length. First, stronger bonds tend to be shorter. 2. The bigger the atom, the longer the bond. Therefore, the weaker they are. I.e., the larger atoms that are involved, the weaker the bond is going to be. Lone pairs on adjacent atoms weaken the bond. Finally, double and triple bonds are stronger and shorter than single bonds. These trends can clearly be seen in this table, showing the different bond dissociation energies and bond lengths of carbons bonded to other elements. See how many of these trends you can spot in the table. And now, knowing that a carbon-carbon bond has a bond dissociation energy of 339 kilojoules per mole and a bond length of 1.54 angstroms, is carbon-silicon bond stronger or weaker and longer or shorter than the carbon-carbon bond? Use the periodic table to help you answer the question.